Hello, my name is Kostas and I work as the technical artists teacher here at the Game Assembly in Malmö, Sweden. This video is going to be about getting started with ShaderFX for Maya. This is going to be the first part, which is about how to work with ShaderFX shaders. If you're not familiar with ShaderFX shaders, it's the real-time shaders of Maya. So shaders that would be like game-like shaders that you can view in the viewport. This example is one shader I created a long time ago, which was basically an exercise for my students to break down the TF2 type of shading. So I would, break it down into different parts where I show them the different, if you were to layer the entire effect of the shader, and you could step through and have a look at the different parts of the shading and then finally see the composed shader. The interface for working with these type of shaders is this node-based network, something like this. These are groups, so within each of these groups you'll have several different nodes and components. But this is more the type of exercise we might do in a later part in this video series. The first part that I'm going to go through today is basically just how to get started with working with these shaders at all. So for that reason, I'll go ahead and go File and New Scene. And I want to start with just showing you this document first. So these are the topics that I'm going to be covering today. So first I'll go through viewport 2.0 render engine settings. Then I'll move on to how you actually create the ShaderFX shader at all. Then how to edit the ShaderFX shader, which is basically opening that window I just showed you how to access that. And there's a slight issue with the hypershade, which I just want to show. Then moving on to how to create the shader nodes. There's an advanced mode, and I'll tell you what that's about. There's something called groups, and I want to show you how to traverse and work with them. I'll show you what a referenced group is and what the make group unique command does. How to connect and delete shader node connections. How to expose parameters, that is, parameters that you want the end user of your shader to be able to access without actually editing the shader network. What different data types there are, or some of the more common ones, and two important nodes specific to working with data types, which is vector component and vector construct. So I'll jump back to Maya. And the first part which I mentioned is the viewport 2.0 render engine setting. So if I go to Windows, Settings, Preferences, and go to your Preferences in Maya, if you click the display option on the left and scroll to the very bottom, you'll have viewport 2.0 render engine. By default, I believe this is set to the OpenGL core profile compatibility. I want to mention that you might be fine with using this one, but at least in my experience in prior versions of Maya, there's been some features, some things you do in ShaderFX which cannot be correctly displayed in the viewport unless you're running DirectX 11. So I usually just stick with setting this to DirectX 11, as I believe this gives me most possibilities of actually showing the results of my ShaderFX shader. If you do change this, you'll need to restart Maya as well. I've already done that, so I'll just move along. So the next step is going to be how to create a ShaderFX shader. So for that reason, I'll just create whatever type of object, a polygon object, like a sphere. I'll then go ahead and right click, or you can do this via the hypershade. I'll go assign new material. I click you have it here, otherwise it's under Maya, but it should be at the top of your list, ShaderFX shader. As you add that, you would get the ShaderFX shader here as you would with any material you add in Maya. And if you go to this tab, this is where you access the actual shader authoring interface. So it's as simple as creating any type of shader. You just select the ShaderFX shader to create it. If I click this button, I open this dialog. And as you can see, this is a node-based interface, similar to how various other shader editors from game engines, say like Unreal, use this type of node-based interface. It's becoming quite common. I believe that it's here to stay. I think it's a more artist-friendly way of approaching creating shaders rather than writing HLSL code directly. So one thing I want to mention, if you're using this type of interface, if you're doing it the way I do, you should have no problem. But if you do run the Hypershade open at the same time as this window, you'll run into some issues. And I'll just simulate this issue so that you're aware. So if I go Windows, Rendering Editor, and Hypershade, I've now got the Hypershade window open. And the Hypershade, if you're familiar with it, you have different UI areas, right? And if you edit nodes here and select them, you'll have this property panel, which will show you like context sensitive properties for whatever you've got selected in your node network. Now, if you select a node here, it'll update in this property panel here. So as I select the color, you can see that I've got the color and I can select the color. And as I'm selecting, say, the traditional game surface shader, you can see that this context sensitive property panel is updated. It's not updating over here though. And it does update as long as you don't have the Hypershade showing, which can throw you off, especially if you were to start out working without the Hypershade and you get familiar with using the attribute editor. Then all of a sudden say that you have the Hypershade, maybe worst case you've minimized it, and you're sitting here and you're wondering why can't I see my properties? So I'm not sure if this is a bug. I would categorize it as a bug, but for some reason, if the Hypershade is open, and I believe it to be specifically the property editor, this is not going to update correctly. You might be fine working with the Hypershade, but I, for one, prefer just having that one closed, and then as I select these, it'll update in the attribute editor here. The other option, which I personally find viable as well, is just ditch the attribute editor completely. And then in the ShaderFX interface and window, you'll go settings and show property panel. And then it's kind of docked to the Hypershader, the ShaderFX window instead. I could go ahead and maximize this. I mean, usually I would work with two screens, and I might have this window on one screen and the attribute editor on the other one, or some combination of it. When working with one screen, I usually go for the property panel, as it's easier for me to maximize it, not having to handle having the attribute editor in the main window here. So yeah, that's it for how to edit them, just to open the window and get started. As you noticed, when I create a new ShaderFX shader, there's already some nodes and whatnot in this interface. That's because, yeah, as soon as you create ShaderFX shader, you get this traditional game surface shader from Autodesk. And it's quite a powerful shader. It has a lot of stuff going on, as you can see. And sometimes you might be fine with just having this, a base of lots of shader calculations, and you just want to edit the input. So basically, this shader is already doing a lot of, calculating light, calculating specular, handling a normal map, etc. And you might just want to, set your layout of textures or texture packing or just some custom input for some scrolling texture or whatever. And that might be fine. But I'll show you as we move along how you can just ditch this completely and do it from the ground up. But I'll just leave this for now. So next point I wanted to show was just how to create nodes. It's not that hard. It's basically finding your nodes here. You can scroll through the list or just filter with this one. You can right click as well and find the same type of nodes by doing this. There's no search feature when right clicking as far as I'm aware. So if you do want to search for a specific node, you use this interface. So say that I want a multiply node. I will start typing multi or mult and it'll filter down and show me the multiply node. And it's just a matter of left clicking and drag dropping that node. To move the nodes around, you would just have them selected, left click, and move them around by dragging with the left mouse button. So that's really intuitive. I could search for add node, for instance, or if I wanted a texture map, I would type texture and I find texture map. So yeah, that's basically how you create the shader nodes. You can copy paste them around with Control C and Control V. I would advise you to never cut though. As far as I'm aware, let's see if I can simulate this error. As soon as you Control X, it closes the entire ShaderFX window, and for some reason this one turns green. And if I'm not mistaken with Maya, that's to indicate that there's no shader applied. So I'm not sure if it's, cutting the entire ShaderFX shader off the object or whatnot. If you do manage to do this, and you might do that by mistake, just hit Control Z, and it should pop your ShaderFX shader back on your object, and you'll just have to open the window again, and there should be no damage done. but avoid using the Control X for cutting. But Control C and Control V is fine for copying, pasting. So next point is the advanced mode. So if I go to settings, there's a toggle advanced mode at the bottom. And if you hit that one, you get a lot more nodes. You get a lot more, low-level technical nodes that your average shader user might not be that interested in using. But some of them we probably will be touching on and using. And so that's one of the parts why you want to use the advanced mode. The other part is, if you notice on these nodes, you suddenly get this button as well. So if I hit settings and I disable advanced mode, you'll see that that button is not there. And that button is there to indicate that you can enter inside of this group. You see it says group here and it has its button. That indicates that it's a group, and if I click, I'll go inside that group. I know that I'm inside a group because I've got this exit group text here. I can also see on the left hand side that this is my inputs into the group and these are my outputs. So I could hit exit group and go back to the top. If I go in here, you'll notice that a lot of these are actually groups as well. So I'm one group down, two groups down, say 3 groups down, 4 groups, 5 groups, 6 groups. It kind of gives you some insight into how much nodes and logic there actually is inside of this traditional game surface shader. We likely won't be creating these this type of scope of a shader within this course or this video series, but I just want to show that you can create these monstrous shaders, and if you do want to group them and organize them by groups to make it more manageable and get a better overview of what the shader is doing. So if I'm like at top level, I can at least at this point I can figure out that if it's something to do with the light calculations, I want to go inside the light loop. If it's something with the diffuse lighting calculations, I want to look for the diffuse group, etc. So yeah, that's it for advanced mode. It allows you to traverse and enter the groups. And speaking of groups, the way you create these, it's really simple. You select a bunch of nodes that you have already. So my recommendation would be that you actually first connect let's just try connecting something. First, you connect whatever type of shader network you want. Say that I wanted to add, I'll go through how to connect nodes and what these are in a second. But say that I wanted to connect this and then have that one replace the diffuse color. If I then select these, it's ideal, if you ask me, that beforehand you've connected it and have it working in your shader network. The reason for that is you'll automatically get this as an output, as opposed to doing this, you'll have to manually add your output. I'll show you. So if I add this back, I select these and I go group and create group. You now have this connected already, and if I enter my group with this button, you'll already have this as an output. And any other input, say that you had a larger network of nodes where, I'll just ungroup this, where these were taking input data as well. Those connections would show up as inputs as well. And I can simulate that. If I go for a multiply node, just to add some more nodes, like so, and I will go for, let's say I grab another float like so. And I mean, likely this would be a larger network of nodes, but say that I just wanted to create a group of these, I would get these inputs and that output for free by having it connected and working already, like so. So yeah, that's how you create a group. If you want to edit some properties of the group, you can left click it out here in parent level, and you can rename it here. So my custom calc, or my calculation, for instance, calculation, say my calculation. If I want to edit, say, the names of these inputs to be more of what's actually expected in the input, I'll have to enter the group, and I can click on this left side panel or node here, which is my inputs, and then if I left click on the specific nodes, input connection, sorry, you'll see that I get settings for it here in my property panels, and it should be, if I'm not mistaken, the active socket label. So I could go ahead and say color 1, for instance, and it will say color 1. This one might be color 2, or whatever, light multiplier, or texture tiling, whatever. You have some options also to how to organize them and set the order of inputs. Same with the output, you can left click here and rename it to whatever you want it to say. So final color, for instance, right? And it should show out here as well to make it more obvious what I'm doing, this calculation. Another thing to note about groups is that this one is now a unique node. If I were to save this Maya scene, this group would tag along and work as you would expect it to. But if I were to say use the vertex shader group, this is also a group, like my other group I created myself. But there's one distinct difference, and that is that this, I think the R, there's no documentation of this as far as I know, but I think the R indicates that it's a referenced group. That means that this one is actually saved on disk, and if I were to save my Maya scene, it's not actually going to store it as a baked down, if you will, group of shader nodes in my save scene. It's only just going to reference to that group on disk. Why that is important is because, and I'll show you, if you enter this group, say that you change something inside of this group. Say that I grab this one and add that one here, and then you can actually see it here. But if I exit here, you'll get this red E here. I'm going to take a guess again and say that this is to indicate that it's been edited. But the problem with this is if I save my Maya scene and then I reopen my scene, it's not going to save the edit. It's going to revert to how the group is shaped on disk. You know, the initial, or yeah, the saved version of the group on disk. It's not going to store my edit. So be wary of doing this. If you do edit this and you want to save that change for the edit, your two options are either to update that group on disk to reflect your change, and then it will use your change on all future or all instances where it references this group, or select your edited group, go group, make group unique. Now the R is removed, and that actually means, it actually says down here as well, the group is now unique and no longer refers. All right, so the R is for refers, or reference, right, to the node on disk, which means any kind of edit you do now will be saved in that instance, that Maya save scene. I could still pull this one out and I'll have that referenced copy of how it's shaped on the disk. So this one would not have the change, whereas this one would have the change and work with saving the Maya scene and reopening. So I hope that's not too technical for you, but it's quite common that you might use some of the pre-made groups and then you realize, oh, I want to change this behavior. But if you do, remember to make the group unique or update the group on disk, and that is done with the save group to disk. I'll hopefully cover that in a future video as there's a few steps to it, but say that I made this perfect group here with my calculation and I know that I will want to use it on other shader projects. I could go ahead and save this group and have it added here in my list of available nodes and groups to use. Right, so the other thing I wanted to cover was connecting and deleting shader node connections. So these are the shader node connections. You basically just drag with the left mouse button and drag them onto what you want to connect them to. You'll see that they are flowing in this direction, which is indicated by this arrow. And as I move them around, it'll update like this. The way you delete them is you left click to have it selected and then just hit delete. Another way is obviously if you know that this one is going to be replaced with something else, you could just drag from here, do this, and it'll automatically be replaced. So there might not be a need to actually manually delete them that often as you might think. Also, of course, if I delete this node, it's automatically removed for me. Yep, that's it for how to connect them. Another thing I want to mention is the exposing parameters. What I mean by that is if I were to say open the attribute editor, and I now select my sphere. Let's go ahead and actually close the ShaderFX window to show you. You'll see that here under attributes there are no exposed parameters for me to play around with. So for a user using a shader, you're probably familiar with or accustomed to having a few tweakable parameters, like setting the color or your input textures or your specular amount or whatever it might be. But currently, as this shader is designed, there's no exposed parameters for the user of the shader to play around with. So in order to do that, you would, on your node you want to expose, you need to look for an option called expose. So this one has one called expose as material input. And there are only a few nodes that allows you to expose values. So color is one of them. Texture map is an obvious one. Float values, if I'm not mistaken, allow you to expose them. Float 3 values do not have expose functionality for some reason. So there are, just to reiterate, there are a few parameters or node types that you can expose and other ones you can't expose. So since I'm on the topic of float and float 3 and not being able to expose it, the way you would work around this is you would take 3 single floats and pack them together into float 3, and then you can have these 3 exposed and they're packed together as a float 3. It's a bit wonky or convoluted if you ask me, but that's how you have to work around the issue. Right, so let's try. We have exposed this one. If we now have a look, you can, if you have the ShaderFX window open or editor and you select nodes here, you'll have that context sensitive parameter here. But if you just left click here to have nothing selected in the ShaderFX editor, you will get to see the same kind of options you would if you just close the ShaderFX editor and go to the shader tab on the attribute editor. So this is what your shader user would see. Usually they don't want to mess around with these settings. They just want to play around with the attributes. And here's where your newly exposed color would show up. I would need to be in hardware texturing mode as well to see this. That is number 6 on the keyboard. To change the name of it, change this name parameter here. This might vary a bit as well, actually. It's not that consistent. If I go to texture map, for instance, and I have a look here, let's say we connect this to diffuse color. If I look at this one, I have my texture exposes material input, but different to the color node, this is the name which is shown in the interface for the user, the shader parameter name or attribute name. On the texture map, however, it's not the name, it's the unique name which is going to be shown in the interface if I'm not mistaken. So say that I rename this one to my texture, and then I click here, you'll see that my texture is now exposed. It doesn't care that this one is called underscore texture map. That's not the name it's going to be using in the interface. It's the unique name. So yeah, the name exposed in the interface when exposing varies a bit depending on which type of node you select. So next topic, we're nearing the end of this video, is data types. So you might be familiar with this if you've worked with scripting or any other type of technical interface or technical job, if you will, where you deal with data types. And data types are things such as, I've mentioned some of them already, but floats, for instance. So some of the more common ones you will use are float, float 2, float 3. Let's grab the color as well. I'll just show a few of them here and we can talk about them. Texture map is going to be one of them. Have a texture map already. I'd say that you might come across an int. So these are probably the most common ones that you'll use. A float is just a single decimal value. So here's your float value. An int or an integer is just the integer value. That is a number without the decimal component. So the difference between an int and a float is that the float has a decimal component. This one is a whole number. Float 2 and float 3, and you actually have float 4 as well. I should have that in here as well. Float 4 is actually just more of the same, like many packed float values. So a float 2 has 2 float values. A float 3 has 3 float values that is decimal values, and the float 4 has 4 values. So you would usually have this for stuff like setting the intensity of specular, if you will. That's usually handled by just one float, or the panning speed of an effect, for instance. This float 2 would usually be used when manipulating UVs, as it could represent U and V. A float 3 could represent RGB values, or maybe XYZ values to define a position or a normal direction or something. And float 4 is usually when you want to have RGBA with an alpha component. Well, it could be when you do work with matrices and math as well, when you have 4x4 matrix, for instance. The color is a bit unique. I think technically it's the same as having a float 3. Or actually, no, I have to correct myself on that. It's actually a float 4, and then you can just grab different parts of that float 4. And it also has this color input box. So if I hit this swatch here, I'll get this type of dialog. And in here, I can define, with the more color picking type of interface. On a technical level, though, it's only going to take these values and convert them to 0.0 to 1.0 range, or 0 to 1 range. If you're not familiar with it already, when colors are handled inside a shader, it's not a 0 to 255 range of colors. It's actually 0 to 1, as it's easier working math on those values when it's 0 to 1 range. So this one is going to be equivalent to a float 4, and also you have an easier way of selecting color with a color picker. And if on that float 4 you can either grab the entire float 4, you can strip away the alpha part, or you can just grab the individual parts of that float 4. And lastly, there's the texture map as well. The texture map is quite self-explanatory. It's not technically it's the same as a float 4, if you will, or this color node. It also has the 4 values RGBA. You can, as you can with this one, you can grab just the RGB or the individual ones, and you can of course point to which texture you want to be using. I'm not sure why that button is not showing up properly. This one, my texture path here, should have a button with 3 dots to indicate that you can click and browse. I believe that if I were to look in the attribute editor interface, you can see the button here. Oh, and now it's working properly here. That's odd. Oh well. This one allows you to point to whatever texture you want to use. And you can also play around with changing the input UVs or what mid-map level should be used, etc. I do want to mention that there are some other data types that are not as commonly used, but you should be aware. You have stuff like int value and int value. Might sound like it's the same thing as int, but it's not. Notice how this one has a v and this one does not. There's also a string, which is same as typing an amount of characters or letters, if you will. Could be numbers as well. And there's string value as well. Those are still not the same. Output here would say string, and this one would say string value. Now it actually both say string. So you might come across these, and usually if you're not aware, as you probably noticed by now, you have they're colorized to show which type of data type they are, which is, I think, is a super nice thing. A lot of more bigger shader editors don't actually have this type of color coding. So I think this is completely awesome. It allows me to see directly, this one is accepting a float even without clicking it or figuring it out by some other means. I can just tell by color. So this one would work perfectly for the green ones, for instance. This yellow one for anisotropic spread, etc. And also when you click and drag, you can also see that it actually says what type of parameter it is. So this one will say a float 3, and this one will say a float, etc. Yes, so that's it for data types. Lastly, the thing I want to show, since I did just talk about data types, is the vector construct and the vector component. So I'll just drag both of those out here. So these are used for actually building various data types and reconstructing them, or just breaking them up. So if I have a float 3, I could drag that into the vector part of that vector component, and let me just move this to the side like so. Now what this does, as we mentioned, the float3 has 3 values. The vector component would now allow me to access these components individually. So if I just wanted the z component, that is the third one, you could see this, you could imagine these as RGB or XYZ. Or maybe I want just the, the XY part. Or maybe, if I've just come from one program which has a Z going upwards and I want Y being upwards, I could, swizzle Y and Z around to do something like this. And as you can see, and you probably realized by now, the vector construct is the opposite of the vector component. So the vector construct would allow me to, rebuild or pack data together to more combined types of data types. So for instance, let's say that I have my RGB color here, and I want to define the alpha component using a different source with just a single float value. This one would be equivalent to RGB XYZ, and the alpha would be equivalent to the W. So here I've now constructed a packed RGB A value, where the RGB comes from one source and the A from another source. So that is the vector component will split, a combined data type, and this one will pack together to construct. So vector component and vector construct. So that should be it for the first part of this video series, and that we just talked about how to work with ShaderFX. You should now know enough to be able to start at least creating nodes and connecting them together, and viewing shader networks. And in the future videos, we'll talk more about what different type of nodes are there and how can you use them, and what are some good practices when creating shaders. So I hope you found this useful, and stick around for more videos. Thanks.